Welcome to Month 2 of the Senior DevOps Engineer track, Infrastructure as Code at Scale. Month 2 builds on the Terraform and OpenTofu fundamentals from the DevOps Engineer track and asks the harder questions. What happens when 4 product teams each copy-paste the same Terraform repository and 6 months later all 4 have diverged? What happens when a state file grows to 1,000 resources and one failed apply locks the entire environment? What happens when manual PR review is supposed to catch bad configurations, but velocity means reviewers approve without reading? 5 exit criteria for this session. Designing module hierarchies that teams actually version and release, using Terragrunt to eliminate per environment boilerplate, without hiding what's happening, authoring OPA policies that catch real misconfigurations before apply, operating state cleanly at scale, and seeing drift across every environment from a single dashboard. 4 hours structured across 4 focused blocks. Hour 1 covers module design, the 3-tier pattern, input validation, composition, and testing. Hour 2 is Terragrunt and policy as code, DRY live trees, OPA with Conftest, and 5 mandatory policies. Hour 3 is the hands-on challenge, the Bistec scenario where you build all 4 deliverables using kind and local stack. Hour 4 is state hygiene and review, splitting, lock contention, secret leakage, and the drift dashboard. Prerequisites for the hands-on: OpenTofu, Terragrunt, Conftest, and Terraform docs installed, Atlantis running with a Gitea webhook, the lab repository cloned, and Terragrunt run all in it succeeding in the dev live tree. Verify these before reaching the hands-on block. The 3-tier module pattern solves the fundamental problem of Terraform repositories, where everything is in one root module, and no part of it can be tested or changed independently. Tier 3 is resource modules, thin wrappers around individual cloud resources, a VPC, a subnet, an RDS instance, a Kubernetes namespace, single responsibility, no cross-resource logic. These change rarely and are released with semver tags independently of everything above them. Tier 2 is service modules. These compose multiple resource modules into a meaningful unit, the Bistec Mart platform, which is a VPC plus EKS plus RDS wired together. Service modules are the composition unit that product teams actually version and pin. Teams don't version individual VPC modules. They version the platform as a whole. Tier 1 is the landing zone, 1 per environment. It deploys an entire environment by composing service modules. A senior engineer writes this once, and it becomes the thing you point at a new region or a new environment without rewriting. 4 design rules make this work in practice. Stable input contracts so consumers don't break when you refactor module internals. Semver tags on every release. Outputs as the only contract between tiers, and no cross-tier data reads, which means no Terraform remote state reaching across tier boundaries. 2 mechanisms distinguish production-grade Terraform modules from scripts that happen to use the Terraform syntax. Validation blocks on variables fire at plan time, before any API call is made, before any resource is touched. The first example validates a VPC CIDR. It must be a valid IPv4 CIDR with prefix /20 or larger. If this validation fails, the plan exits immediately with a human-readable error message. Compare this to discovering the same problem 10 minutes into an apply when the Cloud API rejects the CIDR. Validation blocks are the difference between a fast explicit failure and a slow mysterious one. The second example validates the env variable with a regex, must be dev, stage, or prod. This prevents typos like production or DEV from creating separate state files that confuse the drift dashboard. Composition with for each over a map of objects eliminates repetitive module blocks. Instead of 3 identical module blocks with different names, you drive the instantiation from a map. Adding a 4th team is a single map entry. Importantly, for each addresses resources by key rather than index, so removing or renaming one entry does not rebuild everything after it, unlike count-based loops. 2 testing approaches with different trade-offs that serve different purposes. Terratest is Go-based integration testing that literally runs init, apply, asserts on outputs, then destroy. This is real infrastructure being created against a real or mocked cloud endpoint. The test on the slide creates a network module with a specific CDR, asserts the VPC ID output is non-empty, and destroys on exit. The advantages are that it catches real API errors and tests actual behavior. The disadvantage is that it is slow. Real infrastructure takes time to provision, and it requires cloud credentials, or a local mock like LocalStack. The native Terraform test command added in OpenTofu 1 runs in process and supports mocking. It is faster and does not require cloud credentials for unit tests. The trade-off is that mock tests can pass, while real infrastructure fails, which is a known failure mode when teams mock every external dependency. The practical recommendation: use Terraform test for unit tests on validation logic and output correctness. Use Terratest for at least one integration test per module that covers the full create and destroy lifecycle. Both belong in continuous integration. Terragrunt is a thin wrapper around Terraform and OpenTofu that solves 3 specific problems well. It also introduces new problems when misused, so it is worth being explicit about both. Job 1. Backend boilerplate elimination. Every Terraform root module needs a backend block with a bucket key, DynamoDB table, region, and encryption setting, with 30 components across 3 environments. That is 90 nearly identical backend blocks differing only in their state key. Terragrunt's find in parent folders function lets you define the backend configuration once in the root Terragrunt, add sul and inherit it everywhere below. Job 2. Dependency wiring. When the K8's platform component needs the VPC at output from the network component, Terragrunt's dependency block fetches that output and passes it as an input. No Terraform remote state data sources. No manual output copying between state files. The dependency graph is explicit in the file tree. Job 3. Environment duplication elimination. A single run all plan command in the live dev directory runs plans for all components in dev in parallel, respecting dependency order. Run all apply applies them all. One command drives the full environment. When Terragrunt causes pain, circular dependencies between components expose real architecture problems that Terragrunt makes visible but cannot fix. Overusing dependency blocks creates tightly coupled components that defeat the purpose of the 3-tier pattern. And run all blast radius is real. A misconfigured run all apply can touch every component in every environment simultaneously. The live tree is the deployment configuration, separate from the module library. Modules are reusable code. The live tree is the instantiation of those modules for each specific environment. The canonical structure, a root Terragrunt, a sul for backend configuration and common provider inputs, an env common directory for inputs shared across environments, then per environment directories, each containing per component Terragrunt, HTML files. Walking through the component HCL include root, inherits the backend and provider configuration from the root file. The dependency block on network fetches VPC outputs from the sibling network component. The mock outputs section is critical. It allows run all plan to succeed on first run before real infrastructure exists by substituting mock values for upstream outputs. The Terraform source pins the module to a specific Git tag. The inputs block passes environment-specific configuration. The key design property. A single change to the module version in env common propagates to all environments on the next run all plan. One line. No per environment editing. This is the DRI property that prevents module version drift between development and production. The Open Policy Agent is a general-purpose policy engine. Conftest is a command-line tool that applies OPA policies to structured data from various sources, including Terraform, plan JSON. The pipeline is 3 commands: tofu plan outplan to tf plan, then tofu show son plan to produce plan JSON, then conftest test plan .jun pointing at the policies directory. Policy enforcement happens before any infrastructure is touched, at pull request time, not post-apply. The rego rule on the slide blocks sh from anywhere. It iterates all resource changes in the plan JSON, filters for security group rules, checks if any CDR block is the 0/0 wildcard and the port is 22, and emits a deny message with the resource address. If this rule fires, Conftest exits non-zero and the PR is blocked. 3 structural elements of rego. The package declaration scopes the policy. The input document is the plan JSON. Every resource change is accessible at input resource changes. The deny array collects blocking messages. Warn collects non-blocking advisories. Unit tests live in test rego files and use test prefixed rule names to verify both the allow and deny paths. These 5 policies cover the most common misconfigurations that reach production in Terraform repositories without automated policy enforcement. Each one has caused a production security incident or a compliance finding somewhere. The network policy blocks 0/0 ingress on ports 22, 3389, and 5432, SSH, RDP, and Postgres. These 3 ports are the most frequently left accidentally open. This is always a deny level violation. The tagging policy blocks resources missing owner, env, or cost center tags. Without tags, cost attribution is impossible. Ownership of drifted resources is unknown, and cloud bills become unresolvable mysteries. This is a deny in production and a warning in development where iteration speed matters more. The storage policy blocks public S3 buckets and unencrypted EBS volumes. Public S3 is a data breach waiting to happen. Unencrypted EBS violates most compliance frameworks. Both are deny-level violations. The compute policy blocks instance types outside an approved allow list. Without this, developers create expensive GPU instances for test workloads. The allow list is reviewed quarterly and updated via pull request, so changing what is permitted is itself an audited change. This is a warning-level violation. Flag it, but decide whether to block. The secrets policy uses regex to check variable values in the plan for patterns matching passwords, API keys, and tokens. This catches the mistake of passing a plaintext credential as a Terraform variable value. There is no acceptable reason for a plaintext secret in a plan file, so this is always a deny. State management is where infrastructure as code at scale gets genuinely hard. 3 distinct problems require different solutions. State splitting means 1 state file per Terragrunt component, 1 for network, 1 for data store, 1 for the Kubernetes platform. This limits blast radius. A failed data store apply only locks the data store state. It also makes state operations safer because you are working on a focused, smaller file rather than one giant file containing every resource in the environment. Lock contention. With a single state per environment, every apply is serialized. One team's deploy blocks every other team's deploy. With per component state, only applies touching the same component are serialized. 2 teams can deploy their components simultaneously without waiting for each other. Recovery paths. Tofu state pull downloads the state file. Tofu state push restores it. Always back up the state before any state env operation. There is no undo. Never run state-rm on a production resource without a verified backup and a clear understanding of what reconciliation will happen on the next apply. State encryption in OpenTofu 1.7 is native via the encryption block. PBKDF2 key derivation from a passphrase, AES-GCM encryption, applying to both state files and plan files. The passphrase must come from a secret manager or a CI secrets environment variable, never from a TFVARS file committed to source control. Secret leakage through Terraform state is the most underappreciated security risk in infrastructure as code deployments. Terraform stores all resource attributes in state, including attributes marked sensitive, an RDS master password, a Redis authentication token, an IAM access key. All of it, in plain text, in your state file, in your S3 bucket, readable by anyone with S3 read access to that bucket. The sensitive equals true attribute marker hides values from plan and apply output in the terminal. It does not remove those values from the state file. This is a common and dangerous misconception. Detection is straightforward. Pull the state with tofu state pull and grep for common patterns, password, secret, token, key. More thorough, run trufflehog against the state bucket directly, which scans the raw JSON for credential patterns. Remediation follows 3 steps. First, stop the leak at the source. Never put credentials into Terraform managed resource attributes. Instead, use a secret manager like Vault and reference the ARN, or the secret ID, not the value itself. Second, encrypt state at rest using OpenTofu's native encryption, so that a compromised S3 bucket or bucket ACL misconfiguration does not expose credentials in plaintext. Third, rotate any credentials that may have been exposed before encryption was configured. Assume the state file was readable by anyone with S3 access during that window. Drift is the condition where live infrastructure differs from the state that Terraform knows about. It happens continuously. A developer adds an ingress rule manually. An auto-scaling policy modifies a resource count. A cloud provider rotates a managed certificate. Without a drift detection system, you discover drift when something breaks. The architecture is straightforward. A daily workflow iterates every environment in the live tree. For each component, it runs Terragrunt plan with the detailed exit code flag. Exit code 0 means no changes. Exit code 2 means changes exist. Drift. Exit code 1 means an error in the plan itself. An aggregator script collects these exit codes and plan summaries and produces a single markdown or HTML report. The sample output shows the actionable format, 1 row per environment and component, status clean or drift, and a count of additions, changes, and deletions. An on-call engineer can scan the full environment in under 30 seconds. The most important requirement that most implementations miss: the report must be posted somewhere where humans actually look. A GitHub Actions artifact that requires 7 clicks to open is invisible. Post it as a GitHub issue, a Slack message, or a static dashboard page, whichever channel the team already monitors. On-call engineers review the report and classify each drift entry as intentional, meaning a manual fix that should be reconciled back into Git. Accidental, meaning someone edited live state without realizing it, or an infrastructure bug requiring an incident response. Atlantis is an open-source server that integrates with GitHub, GitLab, or Gitea and runs Terraform plan and apply operations directly from pull requests. The key capability it provides over a pure CI matrix is the lock between plan and apply. The problem with a GitHub Actions matrix: on PR open, the plan runs and appears in the logs. The engineer reviews and approves. While reviewing, another PR lands and applies a change that affects the same state. The original plan is now stale. It was computed against a different state than what exists now. When the apply runs, it applies a diff computed against an old baseline. Atlantis solves this by holding a workspace lock from the moment the plan runs until the apply completes. No other apply can run on the same workspace in between. The Atlantis workflow: PR opens, the webhook fires, Atlantis detects which Terragrunt components changed by examining the diff, posts the plan output as a comment directly in the PR, where it is reviewed alongside the code change. The engineer types Atlantis apply as a PR comment to trigger the apply. Atlantis applies using the exact plan that was reviewed, and then releases the lock. The Atlantis YAML workflow on the slide shows the Conftest integration. The plan step produces plan.json, and Conftest test runs the policy bundle against it before the plan is posted for review. The apply step uses the pre-approved plan file, no replan at apply time. The challenge puts the session's content into a concrete production scenario. Bistec has 4 product teams, each with their own Terraform repository. Each repository started as a copy of the same template and has since diverged. 3 of the 4 state buckets are unencrypted. Bad CDRs and missing tags reach production monthly because manual PR review cannot keep pace with the deployment velocity. Nobody owns drift detection, and it is consistently discovered after an incident rather than before. The task for this session: build the version module set that replaces all 4 team copies, the Terragrunt live tree that manages 3 environments across 2 teams, the Conftest policy bundle that catches the 5 most dangerous misconfigurations at PR time, and the drift detection workflow that gives the platform team continuous visibility across all environments. The lab runs on local stack and a local kind cluster, no cloud credentials required. The architecture must transfer unchanged to a real cloud environment. 4 deliverables at 25 points each. Deliverable 1 is the version module set. 3-tier composition realized in practice. Input validation blocks that reject realistic bad inputs at plan time. At least 1 Terratest integration test that creates and destroys module, a readme, auto-generated by Terraform docs rather than handwritten, and semver tagging documented in a contributing.emd file. Deliverable 2 is the Terragrunt live tree. DRI backend configuration, with no duplication per component. Dependencies wired via dependency blocks rather than remote state data sources. The env common directory reducing duplication meaningfully across environments. A 1-line module version bump that propagates to all environments as expected. And state encryption configured and verified. Deliverable 3 is the Conftest policy bundle. 5 policy categories covered with real inspection rules rather than stubs. Rego unit tests proving both the catch and the allow paths. A version policy bundle with a documented update process and evidence of a PR being blocked by the policies. Deliverable 4 is the drift detection workflow, a daily job that runs reliably. Per environment exit codes captured correctly, an aggregated report that is human readable in under 30 seconds. Post somewhere the team actually reads. And a runbook that classifies drift types and prescribes specific remediation steps for each. 6 mistakes, each responsible for real production problems. The giant landing zone module, putting VPC, Kubernetes, RDS, and monitoring into a single module makes isolated testing impossible and collapses the 3-tier intent. If changing a network parameter forces a full environment replan, the module boundaries are wrong. Circular dependencies via Terragrunt dependency blocks expose real architecture problems. When component A depends on component B and component B depends on component A, the architecture needs rethinking. Terragrunt cannot solve a circular dependency, only reveal it. Major version bumps without consumer notification. Consumers pin to a major version with the expectation of no breaking changes within it. Bumping major without communicating causes plan failures that appear as mysterious errors with no obvious cause. Conftest policies that count resources instead of inspecting attribute values. Knowing that a security group rule exists tells you nothing about whether it allows dangerous traffic. Inspect the actual attribute values. SIDR blocks from port to port. State encryption configured, but the passphrase stored in a TF-vars file in the repository. If the passphrase is in Git, the encryption protects nothing against anyone with repository access. The passphrase must come from a secret manager or CI secrets. Drift report posted only as a CI artifact. If accessing the report requires navigating to a workflow run and downloading a zip file, engineers will not read it. Drift detection without delivery is invisible. Today covered the infrastructure layer that sits beneath the Kubernetes platform from month 1. You now have a module architecture that product teams can version, test, and release independently. A DIY Terragrunt live tree that eliminates per-environment boilerplate while keeping the configuration transparent. A policy as code pipeline that catches dangerous misconfigurations before they reach infrastructure. State management patterns that limit blast radius and enable safe recovery. And a drift detection system that gives the platform team continuous visibility rather than post-incident discovery. Month 3 moves to service mesh and zero trust, Istio, Envoy, mutual TLS between services, and the zero trust network model where every service call is authenticated and authorized regardless of network position. The skills from month 2 apply directly. The service mesh configuration will be managed as infrastructure as code, and the Conftest policy bundle will grow to cover Istio resources alongside cloud infrastructure. Before month 3, the offline milestones build directly on today's work. Adding OpenTofu native state encryption for production, wiring Terraform docs into CI so READMEs stay in sync automatically, writing a module deprecation document for managing major version retirements, and completing an end-to-end Terra test covering the full landing zone module.